Hi, in the previous video, we were able to determine or figure out the velocity. What if it's set on a ramp like this one, similar to this illustration on the other side, but only this time we were able to measure the distance between the car along the ramp. And the velocity is assumed to be 1.84 based on our calculation. But what if you conduct an experiment and then you get a different answer? Okay, different answer. What do you think affects the uh, why the velocity are not the same? Okay, without giving you the answer for your next activity, why do you think the velocity is not the same? And how would you prove that by conducting an experiment? Let's say you know this distance. Okay, you know this distance. This distance right here is zero point 0.6. And using uniform accelerated motion, the equation that you're going to be using, okay, is to solve for velocity is to use this equation, which is derived from the 3 kinematic equation. And this will give us 2 delta x, which is twice the distance divided by the time. So when you're conducting an experiment, you can collect the time, and using this equation, you will be able to determine the velocity. But when you're conducting an experiment, at least conduct it several times, at least 3 times, in order to reduce the uncertainty or errors in your work. So what if by chance that when the experiment was conducted, our student who conducted the experiment collected a number of 0.76 seconds. I'm just throwing in some numbers, some possible, and then another student conducted it and was able to get 0.8 seconds. And last but not least, let's say another student was able to measure the time when they were using the stopwatch at 0.7 seconds. So 3 attempts. Now, first thing that we should do is take the average of those 3 numbers. Taking the average of all 3 numbers is to add all of them, and then you divide it by the total number. So in this case, what is the average? The average is simply, well, just to show you, this should be 0.76 plus 0.8 plus 0.7, and then you divide it by the total number of recordings. So that is 0.3. So just to make our table look better, okay, let's extend this so it does look better, much attractive as we call it. So now we can basically say that the average, by adding those 3 numbers, which I'm going to show you, which is 0.76 plus 0.8 plus 0.7. So that's adding all 3 of them since they are inside the parentheses. So that will be our answer, 2.26 divided by 3. So we have an average time of, excuse me, 0.753 seconds. So this will be our average time. So using this average time, now we can figure out our average velocity. Okay, so what's the average velocity based on the recording? Well, velocity is 2 multiplied by delta x, which is 0.6, divided by 0.753 seconds. So then we would have a value of 2 times 0.6 divided by 0.753. Now we have a velocity of 1.594. meters per second. So it does show that based on my experiment, the value of velocity is less than the calculated velocity. So applying our concept of efficiency, now let's figure out how efficient the system is. So it means that there is some energy that is being used instead of just changing it from potential to kinetic. Some of the energy is being used to overcome other factors such as friction, because friction exists, or drag, or any of those losses or parasitic load as we call it, that is going to be that's going to use those energy instead of converting it to useful energy. And that is our objective, is to make sure that our velocity is supposed to be the same as this velocity. So that's where efficiency comes in. In the next video, I will discuss about the efficiency.